Hi, my name is Zivan Ori, co-founder and CEO of E8 Storage. And we're very proud to be here presenting at Storage Field Day 14. And I'd like to thank all the delegates from coming from long and far to Santa Clara. So E8 Storage was founded with the premise that a new storage architecture is needed to be able to leverage the parallelization and performance inherent to flash and SSDs. And many products have tried to do that by creating very sophisticated and complicated hardware architectures, but the main premise of E8 has been to achieve no compromise in terms of usability, in terms of reliability, in terms of availability, and all using off-the-shelf hardware. And that has been our mission since we started. So we were founded 3 years ago. We're a little over 40 employees today. Our R&D center is in Tel Aviv, our headquarters in Santa Clara. We also have sales offices in New York and London. We're funded by VCs. Our last round was led by Excel Partners, one of the largest VCs here in Silicon Valley. The E8 storage architecture, which I'm going to dig into in this presentation, has won already 9 patents awarded and 4 more pending. We also won the Flash Memory Summit Most Innovative Product Award in 2016, and again in 2017 for Most Innovative Customer Use Case and Production Use Case, which we're going to show to you. So I'm Zivan Ori. I, together with Alex Friedman, founded the company 3 years ago. Both of us have come from IBM's XIV storage product, along with the Ziv Serlian, our VP of System Architecture. A lot of the DNA of the company and the lessons we took from productizing enterprise storage under the wings of IBM have helped shape what we've learned into the E8 storage architecture. Also here with us is Andy Flash, our VP of Sales, based out of New York, and Julie Hurd, our Director of Technical Marketing, based here in Santa Clara. So just to start, and we don't have a lot of fluffy marketing slides, this is a story told to us by one of our customers. What they see in their business, and it's kind of a retail business, is that the growth in the actual business is only 5% a year, and that makes sense. It's a very mature business. But at the same time, a lot of their activities are moving to the web, and behind the web, there are large databases powering that. The growth in storage on their website is 60% a year. And more astonishing is that the growth in performance on that storage is 100% a year. And
demand for performance.
yeah.
If they had the same storage and it got twice as fast every year, I'd want to buy that.
Yeah, the demand for performance is growing in a very radical pace. And the reason for that is that more and more of our consumption is moving to the web, and that is generating a lot of traffic on their website and on their databases. And if all of us can relate to that, we generate a lot of queries when we log onto these websites. A lot of those queries are becoming more sophisticated and more multidimensional. If it's on travel websites or retail websites, what would happen if I order it now? What would happen if I book my travel through that place? And this is what's generating such a huge load on their infrastructure. So what the E8 is doing is basically allowing customers to accelerate their fastest growing applications. And we're seeing a lot of interest in several fields. One of them, as I mentioned, is web scale hosted services and large websites, where we're able to scale their performance without sacrificing cost or reliability. We run into applications like Splunk and environments like OpenStack in those cases. Another example is real-time analytics, which has really picked up basically the ability to collect a lot of data and crunch it at real time. We're able to generate 70% better TCO compared to existing solutions. The kind of applications we run into there we'll run a lot into SAS, the statistical application, and we run quite often into distributed and large-scale file systems like IBM SpectrumScale or Lustre. The third use case for us is business intelligence. Parallel processing of shared read-write data is very common in these scenarios. We run into Oracle, mostly Oracle RAC or Exadata, and SAP as the overlaying application. And finally, what is actually our sweet spot today, and we'll show a few examples, anything related to market data and real-time trading. We're seeing a lot of users that really need faster storage and shared storage at that, because the market data is shared between dozens or hundreds of nodes that are all looking at the same market data. There are some applications there that are homebrewed by the customers and some that are off the shelf, like KX develop a database called KDB+, which is common in these environments. So how do customers solve the performance challenge? Today, they're basically torn between two approaches that each have its shortcoming. One is, let's just use local SSDs. They're very fast, they got low latency, they can give you good performance, they're very ubiquitous. And the other one is to put those SSDs inside an all-flash array. The problem with an all-flash array is that while it provides manageability and a lot of features, it is actually diminishing the performance that you could get today from local SSDs. And that is the challenge that customers face. Now, people sometimes look at this and they say, but that's not a fair comparison. A local SSD is just a device, and all-flash array is kind of a rack-mounted enterprise-grade equipment. But if you think of it from the perspective of the customer, it is a fair comparison. For any given application, at the end of the day, they will need to decide whether to deploy that capacity on top of an all-flash array or on top of local SSDs. So even though it's not the same category of products, it is the comparison that customers are facing today.
Well, it's also a question we're constantly asking ourselves.
Of 24 SSDs and each one of them delivers 100,000 IOPS, why do you only deliver 1 million, not 2.4 million IOPS out of that aggregate?
Yes, and we're going to relate to that in a second. So what is wrong with using local SSDs? It's become kind of fashionable. We've run into a lot of customers that have started deploying large-scale databases on local SSDs. To summarize, there's basically two categories of problems in consumption of local SSDs. One is what we call the provisioning problem. Those local SSDs become islands of storage only accessible by that server, much like the SSDs in your laptops are only accessible by your own laptop. That in turn leads to inefficient capacity utilization. Again, the laptop analogy is very similar. All of you bought pretty large SSDs in your laptops because, God forbid, what would happen if you run out of space? How do you replace that SSD? The same thing happens at very large scale at customers' data centers with local SSDs attached to servers. You cannot share SSD content between servers. If there is repeatability of data, you cannot leverage that. And it's very awkward and sometimes impossible to grow local SSD capacity on local servers. The other problem...
That's not the main point. Servers are inherently unreliable, and when they crash, you lose access to all the data that's on that local SSD.
Yeah, that the applications that make use of local SSDs will need to replicate.
Yeah, they have to be application level resilient.
The other topic is coupling of storage and compute. So by using local SSDs, you've basically fused these two domains, and every decision you make impacts these two domains together. So when you buy a new server, you need to determine right there and then how much local SSD capacity to provision it with and to buy at that point. Repair and upgrade requires downtime of both the storage and the compute. And finally, in terms of lifecycle decisions, compute typically gets phased out of the data center after 3 or maybe 4 years. Storage can live 5 or 7 years or even more in the data center. Why throw out good SSDs if the servers need to be replaced? Why make that coupling at all? In the old world of NAS and SAN, all of these problems were solved long ago. Using local SSDs reintroduces this eradicated problems back. What we're able to show is that by using disaggregated flash and moving the local SSDs to a shared component and a disaggregated component, 60% TCO or TCA savings can be achieved because you only need to buy the SSDs when you actually need them. You postpone that purchasing decision to later. Maybe you're never going to need them, but when you do need them, you can buy them at that point in time. And since the cost of components keeps going down, and the cost of flash as SSDs has gone down 20 to 30% every year in the last 5 years, that means that by the time you actually buy the SSDs, they're going to be cheaper too. So as you can see in this graph, the cost for buying SSDs keeps dropping as you postpone that decision further out. You can also improve SSD capacity utilization to up to 90%, and you can use shared volumes instead of replicas, and you can easily add capacity and grow it when you need it. Finally, I think the question that we need to ask ourselves and answer is, why isn't the all-flash array, as we know it today, really the repository for shared SSDs? Isn't that the whole premise of an all-flash array, be a shared SSD? And the answer that we've realized is that all the existing all-flash arrays today, what we call the Gen 1 all-flash arrays, suffer from a very similar problem, which is an architectural bottleneck. The all-flash arrays are composed by one or typically two controllers that front a bunch of SSDs. Every I/O going from the customer servers to the SSDs needs to go through these two controllers. As SSDs have become much faster, these two controllers have become the bottleneck, and this has been exacerbated by the introduction of NVMe drives, which are 10 times faster than what we had before. So it's an architectural limitation that they cannot overcome, and that is what's capping the performance of the all-flash array. And we're going to get into that in the presentation about the E8 architecture a bit later on.